Good
Okay.
morning, folks, and welcome to another Database in Memory office hours. My name is Maria Colgan. I will be the moderator today. Joining me today as our speaker and expert is Andy Rivenes. If you've got any questions, please don't hesitate to add them to the Q&A below, and I will make sure Andy answers them as we go through the session. With that, over to you, Andy.
Great. Thanks, Maria. Hello, everyone. So yes, another Database in Memory office hours. I thought with all of the announcements of 21C, the documentation's out and available, that it would be kind of fun to go through some of the new features with database and memory in 21C, since there are quite a few. Not all of them are applicable to the cloud currently, but eventually we'll see it on premises, and it is documented. So I thought it would be nice to go through the features just briefly, and then we'll probably do some office hours where we do some deeper dives on the different features, because there actually are quite a few that are pretty interesting, and I think will provide quite a bit of benefit to database and memory customers. So with that, I have our database and memory office hours page up here as always. You have the link, but I always like to point out that if you want to go back and look at any of our previous sessions, and we've done quite a few. We've been doing this for quite a while now. Also, resources, if you find you're interested in some aspect of database and memory, you can click on our blog or the documentation. And then, do I have anything else? I guess that's it. So we kind of have a resources page for you, our previous sessions, and that's all available for if you just scroll down on the same URL that you clicked on to join this session. So with that, we'll bring that up and let's see if we can, I don't know if we can, yeah, we'll do a full screen. You probably can't tell the difference, but that way we'll get all of the features there with the PowerPoint. So today we're just pretty much going to go through the different features. I wasn't planning on doing any demos, although I do have some demos that we've lined up. So hopefully we'll do that is kind of a more of a deep dive on each of the features in the future. So with that, we'll go ahead and get started. Again, my name's Andy Rivenes. My email address, you can follow me on Twitter, Maria Colgan, and her Twitter address or Twitter handle. So if you want to follow her on Twitter, she's done a bunch of things lately on SQL execution plans, which are, very important for database and memory. So I would highly recommend checking that out. And with that, safe harbor, but again, 21C is available in various formats. And so we don't really need to worry too much about that at this point. So the first thing I was going to try to talk about was in-memory vector joins. And so this is actually part of a what we call an in-memory vectorization framework. And so we're planning on adding more features to this framework. The first one is in-memory vector joins. And so what that's going to do is we've actually talked about hash joins and vector group bys in previous sessions. And so we've talked about how if we create a Bloom filter, we can turn a hash join into a scan and filter operation. And we can avoid having to probe in the PGA to do the join, the equality, to find out if we have matches between the two tables. And now with in-memory vectorized, in-memory vector joins, we can actually do that with SIMD vector processing. So that can further speed up the actual join comparisons between the different tables we're joining. So I think that's kind of cool. That's an under the covers thing. We're doing that, again, as part of the execution during the scan of the data. So you're still just going to see an in-memory table access in-memory full, but it will show up in some of the session statistics. So you can kind of see whether that was used or not. So we'll dive some more into that at a later time. But that was kind of the first thing I thought would be kind of neat to point out, that we continue to add performance enhancing features to database and memory. So
one quick question, Andy, on that. Since I am just working on a new video about different join methods in the Oracle database, can you just clarify, is the word I'm looking for, are vector joins a new type of join method?
So they're not. So it's still a hash join. So we've talked about, again, the different joins. So you have a hash join, obviously nested loops, but hash joins. And then we also do a hash join as part of a vector group by, but you won't see in the execution plan a in-memory vector join or something. It's actually being leveraged under the covers to improve the performance of the equality predicate, the comparison between, in this case, the sales table and the items table. So we've taken the work out of the probing the table in the PGA and moved it into the scan, and now we're even making that faster. So you won't see a different execution plan join method, basically.
Awesome, thanks.
Oh, and I guess I should mention that because we did talk about in-memory dynamic scans, which for those of you that I probably should have spelled that out, IMDS. One of the other cool things about this is that we can leverage IMDS to do this as well. So now, and if as a quick review, IMDS allows us to parallelize the access to IMCUs. So now we can do parallelization against multiple IMCUs essentially at the same time without having to invoke parallel query, although it still works with parallel query. And so this leverages IMDS as well. So again, looking to speed up the join during the scan of the two tables. So I thought I'd make sure I pointed that out, because IMDS, sometimes I forget that we're so into the different logos and maybe people don't always recognize what that means. The other big one, and I actually did a blog post, it was kind of funny because between all of the 20.3 pre-release version and such, I wound up having to pull it and add it and pull it and add it. So if you were following the blog, you might have seen a couple variations of this. But with 21C, we actually have automatic in-memory, and we've added a new version, or I guess an option, I should say, to the automatic in-memory level to automatically manage tables in the column store. And what's actually, I think, quite interesting about this is that if you set in-memory automatic level to high, we're going to change all of your tables, all of your application tables, obviously not the data dictionary type tables, but all of your application tables, we're going to change those to be eligible for in-memory. So in the past, people have we've talked about the in-memory advisor, and people have kind of complained that, well, I'm not sure what tables I should populate in the column store. I only have this much memory, and I'm not that familiar with maybe the workload of my application. So what tables should I populate? And this feature basically allows you to not have to figure that out. The database will figure it out for you based on essentially the same mechanisms we use for heat map that we introduced back in 12.102 and added to database and memory. It's not heat map itself, but it's the same kind of heuristics under the covers. And so as this kind of shows you with hot data, intermediate data, and cooler data, we'll actually populate the most active tables in the column store, and if we necessary, we'll evict the least active to keep the column store as kind of the biggest bang for the buck. So you get the most active tables and can take advantage of in-memory for the key performance queries that you might have without having to figure that out. And so I think this is really cool. This is kind of our journey to making database and memory fully autonomous or automatic. I don't know which word's the right one to use for that at this point, but it's really quite nice. We think it's going to be a great feature, and you can actually, if you choose to, you can force tables to be in memory or even not in memory by still marking them with the alter table command. So you still, like everything else we do with Oracle, still have some other knobs you can turn if you have some specifics that you want to control, or you don't have to use it. I mean, you can obviously, if you know your application well enough, you can just populate the tables that should be in the column store and not bother. But you could set this and let the database manage it. So I think that's pretty cool.
So 2 questions, Andy.
Okay.
If I'm not mistaken, didn't we have AIM in 18C? So what's the difference now with 21C that I didn't have with 18?
So with we introduced automatic in-memory with 18C, and we actually had automatic data optimization in 12 too. So we've kind of think of this as kind of a journey we've taken with trying to automatically manage the column store. It's kind of funny because we've always said the column store is a store, not a cache, because we populate the entire object. And now we're kind of making it in essence, a cache at the segment level based on usage. So the difference is we've added this in-memory automatic level high option. So prior to, well, with 18C, when we introduced AIM, we had a low and a medium option, and that allowed for automatic eviction or even population of tables that you had marked to be in memory. So you had to mark them as eligible to be populated in the column store. And then if the column store filled up and got full, we would automatically evict objects that weren't active. And if you had marked other tables that were in memory, you wanted to be in memory but wouldn't fit, we'd populate those. So it was kind of part way to this, but this one now we actually will turn your tables to be in memory and then automatically manage the whole thing. So it's a little bit different, and I think quite exciting. I think actually to me this is the coolest feature we're introducing with 21C.
No, it's super cool. But I know myself as a control freak, especially if I've been using in memory for a while, I might be nervous about this being turned on and it evicting stuff that I want. So by default, out of the box, if I upgrade to 21C, what is the in-memory auto level parameter set to?
Oh, it's not set. It's so there's low, medium, high, and geez, I don't remember. None, I think. I think it's none.
I think it's
I'd have
none
to go
too,
look it
yeah.
up. But yeah, so no, it actually, so that doesn't change. So in-memory automatic level by default isn't enabled. So you have to do that. My guess is in the future, we're probably going to enable it by default to high, but we took a more conservative approach initially. And so I'm pretty sure it's none, but there's so many syntax features that I'd have to go look it up in the which obviously you guys can do too. Go look it up in the documentation, since this is fully documented, both in our in-memory guide and then in the Oracle reference manual for all of the initialization parameters. But yeah, so yeah, you don't have to set it. And if you do try to set it, or if you do want to set it, you can still, like I said, specify certain tables so they're always in, or if you know there's certain tables that, you know, they only get used once in a blue moon, so I don't want those to ever even go through the overhead of populating them, you can set those to no in memory, and then AIM will honor that. So if you explicitly set an in-memory, no in-memory option, then it will honor that setting. It won't mess around with that part.
I know, I think it's very cool. And I agree. I think once people get used to it, I think we're all a bit nervous when we hear it's automagic. But once people get used to it, it's going to be set and forget. And they'll get the benefit of all the performance of in-memory without the hassle of having to monitor their schemas.
Yeah, and I guess I should mention, I'm looking at the picture there, something I tend to, because most of the time we're just worried more about the big picture, but it will compress individual columns as well. And I don't run into a lot of customers, because you can do this even without AIM. You can change the compression level of different columns. Typically, folks just do it at the table level. And so AIM will actually look at that as well. And if you have columns that are never accessed, and we're going to actually talk a little bit about that in a future, in another feature for 21C, it'll actually compress at the column level too. So this is pretty sophisticated stuff. So I'm sitting here looking at this going, I should mention that, because that's another way to basically, and we've talked about compression in the past, and it's not a 4-letter word. It's not like some of the other, I don't want to jinx any Oracle features, but basically compression can be very valuable, because even if you're compressed, having it in the column store is way better than not having it in the column store if you're doing, analytic queries where you're scanning a lot of data. So I think that's a good thing too.
Yeah, so it's basically just going to help me save space, right? The data is still there. I still get all the SIMD vector processing, but it's just going to help me save space and make room for other objects that might be useful in the column store.
I mean, because the reality is that we still don't have most of our Oracle customers aren't running around with terabytes of SGA available to them. Actually, I'm kind of surprised it hasn't become, memory isn't that expensive. So, but we haven't gotten to that point yet where we just have a lot of customers running terabytes of column store, terabytes of SGA to be able to have multi-terabytes of column store. We have some customers. Actually, we got one story that's coming out about a customer with a 3 terabyte column store, but that's not the norm. The norm is more in the 500 gigabyte range, even less for some folks, because realistically, Oracle database hasn't needed to have large memory footprints. And so, even though memory is cheap, it's not, or I should say, memory has become less expensive, but it's really not cheap still. So we still don't see, I think that's going to change, and maybe with PMEM, it'll change even more. But yeah, so anyways, I digress. So what else we could talk about? In-memory hybrid scans. This is actually kind of goes with the idea of saving space in the column store and being able to, you can exclude columns from being populated. And in the past, if you did an alter table in memory and then did a no in memory and had a list of columns that you excluded, if you queried those columns, then we couldn't do an in-memory access for that table, because if you had those columns that you excluded in the query. So in this case, say you exclude invoice, and then you try to select invoice from sales. We can't do an in-memory query based on the price and just go pick those values up. With in-memory hybrid scans in 21C, we can, which is really kind of cool. And it shows up in the execution plan. So you'll see that you actually were able to use a hybrid scan. So we scan the table in the column store, and then for those individual rows, or essentially column values, but essentially rows that occur or are returned, we can go pick up those individual values, those projection columns, from the row store. And so some people will say, well, does that make sense? And it can be quite useful to have that, the ability to mix and match that. So because basically the whole point of folks excluding columns was to, again, save column store memory, save memory, because maybe you don't access those columns very often.
That seems very cool. It seems to me, and correct me if I'm wrong, we're kind of using the in-memory column store like an index lookup, and then using that to just get the individual rows we need from the table. Is that a good way to think about a hybrid scan?
Yeah, I think it is. Yeah, so we don't, use B-tree indexes, but actually with the ability to push, like in this case where price is greater than 1,000, being able to push that into the scan. We've talked about pushing predicates before. We're going to get, say, a small number of column values, or in essence, row values back, and then we can go just pick up individual values from the column store or from the row store. So yeah, it actually acts like an index, but you get the fast scan ability of database and memory, which for especially if you're doing a more complicated query, can provide way better benefit than having to plow through an index, access the rows, go traverse those rows and figure out, well, I don't really need these values, so I can throw away things. So it can actually be quite a bit faster. So you kind of get a mix and match. It's not going to be necessarily the always chosen. It'll be based on cost. And so just gives us another tool in the toolbox.
Awesome. And speaking of cost and performance, what is the performance of a hybrid scan like? Compared to a full in-memory scan and versus a full table scan on disk?
Yeah, so I've had some internal questions about that. And so clearly it's not going to be as fast. If you put all the columns in the column store and run your query, that's going to be the fastest way to go. But it's going to be way faster to go get just the particular column values from the row store than if the whole table had to be accessed from the row store. So that's kind of why we've gone this route, because it gives us another ability to give you better performance than just a row store query, even if it was an index access, because there's a certain point where the index access becomes more expensive than just doing a full table scan. And so this is, again, one of those mix and match kind of things where the cost will dictate, do we look at that query fully in the column store? If maybe columns are excluded, instead of having to go fully from the row store, we can make it a, kind of a best of both worlds kind of thing.
Okay, so somewhere in the middle between a full in-memory scan and the buffer cache. So we still get the performance benefit without having to have a massive in-memory column store.
I know that we get to all these, we start talking about all these features and they all seem so complicated, but the reality is, if you're short on space, exclude the columns that don't make sense to always have in the column store, and Oracle database will take care of if does it make sense to use a hybrid scan. You don't have to know that stuff. The optimizer is going to take care of that and make that decision, and you'll see it in an execution plan in this case, but you don't have to know anything about it. I mean, that's kind of the nice part about most of our in-memory features is you don't really have to know what's going on unless you really want to. We'll do it automatically for you.
That's probably the best part about it, right? Is that all of these performance enhancements happen automatically and you don't have to worry about setting it up in a special way or creating indexes to be able to get that performance. Speaking of indexes, there is a follow-up question to this. Is there any investigation in 21C related to moving the indexes to memory like the tables?
Yeah, no, there isn't. We have, I actually do this in the hands-on labs, and you can try that in our live lab environment, but we have in-memory storage indexes where we keep track of the min-max values for each of the columns in the IMCU. So we kind of have some index access, but as far as moving B trees and bitmapped indexes and that kind of thing into the column store, because we're doing a table access in memory full, because we're scanning the column, just the columns that are part of the query, that isn't, and remember that the target for database in memory is analytic queries where we're really focused on scanning lots of data using aggregation and filtering to just get to the data that we're interested in to do analytics on. Indexes just aren't, that's the row store. So we're not looking at that, and we don't think that's the right way to go with the database in memory features. So
one last question on this before I let you move on, Andy. The in-memory hybrid scan slide, the one that we're looking at right now, the last bullet there says there's a 10x performance improvement with hybrid scans. Can you just clarify if that's versus disk or 10x better than previous versions? That's what they're asking.
So some of these slides I get from development and I change. Some of them I try to do myself, although I'm not as good as you are, Maria, doing slides. But so that would be 10x performance improvement can occur over just a row store query. So I guess I will, actually, I'll just put a note on there to qualify that, because sometimes we have performance numbers like that, and we're always trying to look, does it make sense to do a feature? Are we actually going to get any benefit out of it? And we don't always necessarily qualify that. So thanks for pointing that out, and I will qualify that it's over 10x performance improvement versus a row store, a pure row store query. So and I will qualify that. So, and that's kind of the whole point, right? It's you can, rather than being all or nothing, that hybrid or that mixture can still be significantly a significant benefit. Because if you're doing basically all the work and you're looking at active rows that are in, say, the buffer cache, you're not having to do I/O to fetch those column values. You can go right into the buffer caching and get those column values. Versus it is possible that we'd have to go to disk, but it's a row ID access as opposed to having to scan that table in the buffer cache or row store. So I will qualify that because that's a good point. Let's go to the next one. JSON. So in 21C, I won't go into the details. I've been actually looking at this quite a bit recently. There's a new JSON data type. So in the past, we supported JSON and Oracle database with varchar2 and clobs and different text-based data values. And we even did a pretty sure we didn't ask Tom, and I did a blog post on the fact that you could even use up to 32K, depending on the data type of data, JSON data, and populate that in the column store. In addition to that, there's now a new JSON data type as part of Oracle database. So not in memory per se, but Oracle database. And we're supporting that JSON data type itself in the column store as well. And so it's limited to 8K because it has to fit in the block as part of a JSON data type, as opposed to the way we do non-JSON data type data. That makes any sense. And I don't want to go into too much detail, but we support all of the other queries that we supported in JSON data without the JSON data type. And then I've got another, actually I probably could have reversed these slides, but the JSON text contains is kind of cool because we also have, and I'll talk about in-memory full text columns, the ability to avoid having to create specific indexes separate on the JSON data. We can actually do that in the column store. And so we also support JSON text contains access of the JSON data as well. So, but bottom line is it's perfectly feasible to do analytics on JSON data in Oracle database. We've had that support for a while. Even in memory. And kind of the point of the slide is that we're also now supporting the JSON data type directly in the column store as well. So hopefully that's clear.
No, I think it's pretty clear, at least I hope it is, but there is a question about, I don't have to do anything specific to my JSON column in order to get this. Do I simply just put the in-memory attribute on the table with the JSON column?
Yeah, the only requirement, and we have it documented in the column store, is that you have to have enabled the ability to use in-memory expressions. So, because what we're going to do under the covers, not for in-memory per se, but for JSON data, is we're going to create a binary version of it in a virtual column. And so we need to get that virtual column into the column store. So to do that automatically, you need to set the in-memory oh nuts, I'm going to forget the parameter name. I was just using this too. But if you go look at the in-memory expressions, the requirements were there's to enable I'm not even going to guess, because last time I guessed wrong. So if you look at the documentation, the bottom line is that you need to set an initialization parameter that's associated with in-memory so that we'll automatically populate your virtual columns, and then this will automatically work. So I'll leave it at that, and I don't want to misstate the parameter name and screw anybody up.
Sure. In the recording, we can add it.
Oh yeah, I'll put a little a blurb like I do sometimes to say what it is. Good point. I don't want to spend. I hope I'm not boring anybody. I think we're doing okay with time. In-memory external table support. We have a few more features. Like I said, I mean, it's funny because in 21C we added a lot of additional features to database in memory. And so there's quite a bit to look at. This is probably one of the big ones that folks were asking for. We've supported external tables, but we didn't support partitioned external tables. And so not only do we allow you to pick and choose, you can create partitioned external tables, and you can populate just say the most current data types for in-memory population. And so that kind of the big deal there is that you don't have to then materialize that external data in the Oracle database first. We'll directly populate it from the external source. But we also support hybrid external tables. So that's the case where you might have a mixture of partitions that are local, that are populated in the column store or in the Oracle database, that are in the Oracle database, and that are external. And so you can mix both hybrid external tables and partitioned external tables. We have support for both within memory. So that can give, there's a lot of folks that either have external data that they would like to be able to run analytics on, or perhaps they're migrating, not migrating all of their data into Oracle database. So I think that's kind of a cool feature, was kind of a missing piece to our in-memory external tables feature.
So quick follow-up question on that, Andy. I know when I've got a regular partition table inside in the database, I can specify the in-memory attribute on just one or two of those partitions that I would consider, my hot data. Is that capability still possible if I use a hybrid partition table or an external partition table?
Yes, yes. So you can specify it at the table level or at the partition level. So yeah, that's supported at the partition level as well. Yeah, actually I have that right. In-memory attribute can also be specified for individual partitions. So I actually even put it on the slide. So if you're looking at this later, yeah. So that's actually a good question because, it's sometimes not everything is available the first go around. But yeah, so we made that pretty flexible. So I think this kind of completes our ability to mix, at least in the column store, external and database data to do analytics. I think it gives us a good, I don't want to use the word big data, but because I'm not sure that's still the right thing to say, but a lot of folks have a lot of external data that they would like to do analytics on. So, all right, I forget I have to actually hit enter to go to the next one. So this is in-memory full text columns. So actually, I don't want to go down the converged database paradigm, but we actually are talking quite a bit in Oracle database about the converged database. And so the database and memory development team has spent quite a bit of time working with other groups in Oracle database to include, essentially non-traditional relational data, kind of we have our traditional data types, but then there's things like the context option or the text option. It's kind of changed over time, but we're actually supporting in-memory full text columns. So if you have text data, which you can populate in the column store, we'll actually populate an index into that data, which can help you with performance of accessing that data. So it can be done in memory. So this is something that is kind of a cool start to incorporating more non-traditional data types into the column store. And we're again leveraging, kind of like what I mentioned with the JSON data, the in-memory expressions framework, if you will. And so you do need to add we're going to create a virtual column. So we're going to populate that virtual column as our text index. So you do need to set those in-memory expression parameters, but again, it's all documented. So if you want to experiment with this, it's actually quite interesting in being able to get even faster performance than if you had to create separate context indexes to access the text data in your applications.
So Andy, you say that it improves the performance of text queries. Can you explain to those of us perhaps who haven't used text in a while what a text query looks like? What kind of syntax is in it?
What kind of syntax is in it? I should flip over to, you're going to stump me. I have an example. I don't do a lot of text, so, well, what the heck? See if I can find this fairly quickly. Would that be okay, you think? Trying to find.
Absolutely. I didn't mean to stump you.
No, it's hard to. I find it's much easier to see. I did a bunch of. Here we go. Actually, you asked me to do these, and we did this, and I'm going to bring these out, but I think I won't get in trouble for showing. Spatial, which we'll talk about in a second. But let's talk about, we might as well. So with in-memory full text columns, I mentioned JSON text contains, and I should make this bigger so you can see it. So you have a contain, so you're running a query where you say, I want to look at that text data and it contains a clause that I'm interested in. And so we support these different data types. So the query, whoops, shoot. So the query might look like something like a select count, where in Chicago data, actually, this was a data set I took from Chicago police. It was a free data set off the internet, but where you might want to see where the description is, or the district is a certain district, and whether battery, so like some kind of a crime that occurred, right? So with that right there, a description like, if you actually, I'll see if I got the right example. Sorry. So normally, if you did the like, we just have to go through and search the column. But with a contains, which is basically the same thing, it's essentially a like, slightly different syntax. We'll actually go through, and you can see this in the execution plan. Notice it's table access in memory full, but we're going to use a built-in context. That's actually the virtual column there that's in the column store. Hopefully, can everybody see that?
Yeah, do you want to go full screen just for the older members of the audience like myself, where we may not be able to see?
Well, it's not just you, believe me. But yeah, no, so check it out. So then you'll see in the execution, you'll see this context index, which we didn't create a context index because we enabled this in, and I should go back and might as well, since we're going all the way with this. So if you tell the database that for the Chicago text column that or the table that we're going to add it in memory, there's a special text word that you can put on there, and for description. And so it'll use, actually this is optional for a policy, but it kind of looks kind of like the context that you would do with Oracle text. But instead of creating it in a separate text index, we're going to populate this in the column store as another virtual column. Hopefully that makes sense.
So it does, actually. That's very awesome. So we're effectively getting a text index without having to spend the time building it and maintaining it on disk. That's awesome.
Right. And then you'll actually see the use of that. So now you get it in memory speed and essentially an in-memory expression, rather than having to go and search that context index on disk or in the row store, if you will. And so we combine then the in-memory or text with database in memory. So we're calling it in-memory full text columns, but you basically can identify one or more columns that are going to be text-oriented, and then we'll create a text index. We worked with the text folks on this in the column store. So you had me stumped because it's way easier to show a picture of this. And so, yeah, so it's actually really cool. And we're using the same kind of, I'm actually not going to even leave this. I'm going to stay here, since kind of the next thing up was in-memory spatial. And since I have the examples here, I might as well just stay here and full. So we also support in-memory spatial tables. So now we have JSON support, text support, and spatial support in the column store in memory. And so with an SDO filter operation, you can actually search for geometric points in memory in the column store, as opposed to having to go out and access that separately in the database. And so that's we think that's pretty cool as well. And it's the same kind of idea. You actually create an index, but you give it a special, whoops, wait a minute, that's the old way of doing it. But the new way of doing it is to just alter the table as in memory. And if it's a spatial column, we'll actually set up the, sorry, I'm gonna fumble this a little bit, but we'll set up the spatial index, if you will, in a virtual column. You can actually see the virtual column. It'll show up as that right there down below. I don't know if you can see my, problem is if I highlight, if I highlight that, it'll, oops, shoot, it will click me out. So I'll just say, I'll show you that picture in a second. So for city points, it will actually access the spatial index that's populated in a virtual column in memory, rather than having to go outside to a spatial index in the row store, if you will. And so we'll make use of that, the spatial index, if you will, in the column store. and then that shows up as a bunch of in-memory virtual columns. Well, it shows up as a bunch of virtual columns that then we populate in memory to allow the geometric points to be accessed min and max. You'll see the min and max. And actually, there's the right syntax. You'll say, so alter tables, so in my case, I used city points, which is the same example that's in the spatial and text user guide. I think that's what it's called. And then what you say is in-memory spatial, and you give it the column, and then we go through and create these indexes basically through virtual columns that we can then populate in the column store. Does that make sense? I haven't had to do this yet, so this is all on the fly.
It makes sense, but sorry, I'm being distracted by lots of great questions coming in the Q&A. Right. But actually, you've kind of hit on one that I was just answering, and it'd be good to kind of get your opinion on this, Andy. The question is regarding the overhead. So we're talking about converting text and JSON and creating these binary virtual columns in the in-memory column store. Right. And the question is, can you talk a little bit of the overhead there is on converting text and JSON to these virtual columns, both in the population and in the access? Can we expect overhead, or what that overhead might be like?
So the kind of the cool thing with JSON is that we're going to create under the covers when you create a JSON data type, or you put the is JSON constraint from before the JSON data type became available. We create a virtual column, an OSON, we call OSON, Oracle Sequential, I don't remember what it's called, OSON versus JSON, a binary format of the JSON data. And that's all done under the covers by the database. So that's really not an in-memory overhead. And then these options, both for spatial and text, will be created at population time. So there's some additional overhead for population, but again, as we've said, once the data is populated, then there's no additional overhead associated, except, of course, since we're populating these as in-memory expressions, in essence, the virtual columns, we are going to take up more space. Nothing, as you like to say, nothing in life is free. And so it will take additional space, but you're trading that space. And this is all essentially binary data, so it's not as large as it would be if it was text data. But the binary, so it will take additional space, but you're trading that space for speed. And so typically, that's kind of what you're after, is to get these the highest performance. And so I think it makes that makes sense. But again, I mean, it is ultimately memory, Oracle database architecture, and it's computer science. So we have to stick it somewhere. And so what we're doing is we're then populating the in-memory spatial index, or the text in-memory full text column, text index, if you will, and the JSON data in binary format into the column store to provide that speed up. So do you think that answers the question? So we're trading a little bit of population time, which is really a kind of not that big a deal in my opinion, since it's kind of a once at a, you know, we initially populate it. Sure, if the data changes, we'll repopulate individual IMCUs and IMEUs, but realistically, that's all background processing. And so then the only other trade-off really is space, but space trade-off for speed.
Great. So I got most of that in the answer in Q&A, so I'm glad I asked it to you as well. Okay. I talked about the overhead on population, but the space is the other big part of that too.
Yeah, so I've now gone completely off
Sorry, I've derailed you completely.
No, right? That's no problem, because actually that's you know, and we'll probably do some sessions, and I'll actually run some examples with SQL Plus, or actually I'm working on some Apex, and maybe that'll be an easier way to look at this. But so we got kind of the high level view here. Whoops, I'll go back. We did in-memory spatial. We did in-memory full text columns, but you got kind of more details, because I actually have experimented with this quite a bit in order to kind of understand what's going on. And so we'll make some good demos for some future Ask Tom sessions as well, I think. And then I don't want to forget two other things, because I know we're we're going to wind up going for a full hour, and I always think we'll make these quick so people can ask. Hopefully they'll let you still ask your questions. But we have the base level feature, which we talked about a whole bunch. We've backported that to 19.8, so that allows folks to use 16 gigabytes of column store without having to license database in memory. You have to set a couple parameters to the memory force parameter to enable that. But that's kind of cool. But again, no point in spending too much time on this because there are 2 Ask Tom sessions we've done, plus some blog posts. And then the other one that's kind of cool that people might have missed is the ability to, if you're an Exadata customer, you still have to license database and memory, but for customers that are tight on memory and want to take advantage of database and memory formats in Flash, but don't want to allocate the column store, we've now, kind of similar to the base level feature, we're allowing you to set cell memory level, and then we'll only use Flash for columnar data. So that's kind of an interesting, I think, feature that probably isn't going to get noticed too much. But for Exadata customers who don't want to allocate a column store, but still want to take advantage of database and memory, vector group bys, Bloom filter pushdowns with their hash joins, and take advantage of those formats in Flash, they can do that. So that's kind of more of a minor feature, but I thought I'd highlight it because it is there in the documentation, and folks might not be aware of it. So I think that's all of the, yeah, so that's all, and that's actually quite a few features. If you think about it, we've got, if I go, bear with me, but if I go back, I mean, we've talked about a whole bunch of new features in database and memory, in-memory vector joins, AIM, hybrid scans, JSON, in-memory external tables with partitioning support, full text columns and spatial, and then of course we have the base level feature and cell memory. So that's a lot of new features that we've released. It's like, I think that's a big deal. And always I'll just put that up and see if we have any other questions. I just like 40, almost 50 minutes I've been talking with all this. So
no, it's a lot of really cool stuff. You guys have definitely been busy. But we do have a couple of questions in the Q&A that I thought we could chat about just to wrap it up and to give anybody who hasn't asked a question a chance to type it into the Q&A if they want. Roger's asking, you did say that there is 16 gigs of in-memory free with this base feature, with the base level. Can you let us know when or if it's been backported to 19C?
Oh, yes. And we did, yeah, sorry. I guess I maybe glossed over that. So with the 19.8 RU, the in-memory base level feature works in 19C and then obviously works in 21C. We had it in the 20.3 pre-release, but that was all cloud, so it didn't make any difference for most folks. So yeah, so 19.8, we do have an Ask Tom office hour session that we did, and I showed it's actually an example using 19.8, and then we also have I have a blog post out there as well. So if you want to dig into some more information and an example, feel free to go check out that. It is documented, although I don't know if the 19.8 is actually in a documentation, maybe in a Moss note, but it is available. So
awesome. And just for anybody who doesn't keep track of those, that's the July RU. So last year's July RU, anything from then onwards will have database and memory.
Right.
On the same topic, are there any changes with the licensing of the free amount of in-memory in 21C? I'm guessing the question really is there any increase in the amount of memory I'm getting?
Oh, no. So you get so yeah, database and memory is an option, and in Oracle speak, an option, something you have to pay for in addition to the Oracle Database Enterprise Edition database. So that all stays the same. I would love to make database and memory free, but that's not something we have anything to do with. So, but what we wanted to do and what the development group wanted to do was we think there's so much value in database and memory that we wanted to, and it seems to be a hurdle for some folks to be willing to license or pay for database and memory without having seen some value from it. And so our intent with this is to give folks some amount of database in memory without having to invoke the database in memory license. So you don't have to license the option up to 16 gigabytes. And remember, with RAC, it's 16 gigabytes per instance. With PDBs, it's 16 gigabytes for the CDB,
right?
And then each of the PDBs can use up to the total of the 16 gigabytes in the CDB. So it's fully multi-tenant support, RAC support. So the idea is that not only do you get the column store in the 16 gigabytes, but you could also then, you'll get vector group bys, you'll get hash join pushdowns with Bloom filters. So you could hopefully see the value that in-memory provides, and then that would make help justify wanting to license database in memory. Do you think that covers?
Definitely.
Walking around the licensing. And
I thought you did a very diplomatic response. Okay. But unfortunately, now that we've opened that can of worms, I have a few more questions in that space for you. Can we hope for the backport of any other 21C in-memory features to 19C?
That's a good question. Nothing that springs to mind currently. I know, because it's, 21C is one of our innovation releases, and 19C is our long-term release. So the group, so I work in the database development group that's in charge of database and memory, and they are looking at backporting different features, because we do recognize that 19C is a long-term release, but not that I can tease at this point that I can think of. Most of these features, because we're laying the groundwork under the covers, it's very difficult to go back and change previous releases. So it's not, the in-memory, the base level feature was actually pretty simple because it didn't require a whole lot of re-engineering. But to some of the other features are, as you kind of seen, are much more involved. And so backporting those would mean a whole lot of different changes. And I don't see anything else probably moving backwards that I know of at this point.
Yeah, that's fair enough. You never know.
Yeah, you never know.
But so back to a bit more on the performance and in memory and how it works kind of questions now. Regarding the JSON, if I bring JSON into the in-memory column store and I use a higher level of compression, what will be the performance impact on that? So for example, if I use high compression on that table with JSON.
So the JSON is stored as a binary, I kind of mentioned as OSON, as a binary format. So while you'll get compression on the other columns, you won't get any additional compression. I actually might have to go double check on that, but the JSON virtual column, because that's what we're populating in the column store in OSON format, isn't going to change in its compression. The other columns that you might be populating obviously would still take advantage of that.
Awesome.
I wrote it down, so I should remember that.
Speaking of that, before we run out of time, because we're getting close to the top of the hour, do you want to remind folks where the recording from those previous sessions that we've talked about this today and where this session will appear?
Yeah, so on the landing page that you would have typed in the URL to get to our database and memory session, like join the session, remember that right here down below we have all of our, so it'll show up right here, so you'll be able to click on that. Notice there's videos for all the previous sessions we've done. So that's the right answer, right? I mean, that's how I would tell people to do it. I don't think there's any other, so we see a different version, but so you could just click on the 21C new features, which is what this page is, or you can just click on the video button if you want to look at the video. And as a matter of fact, for the question that was on the base level, there's one of them there, and then that one right there, the 19C one, will show an example with 19.8 running the base level feature. So you could go click on that. We also have the blog, which I've done a couple blog posts on the base level feature. And so, yeah, so is that Good, do you think?
Yes, that's perfect. That's exactly what I was looking for.
Okay.
And uh, that's it. As far as I can see, I'm just clarifying for Roger about the PDBs and CDBs. So it might be worth just chatting about that for a second, Andy. So if I have that 16 gigs of free in-memory column store specified at the CDB level, can you talk a little bit about the PDBs? In other words, do all the PDBs need to use it? Can I exclude some of the PDBs from being able to use it? And what do they all see?
Sure. So it actually works the same with regular database in memory from as far as a multi-tenant architecture works. So because the CDB or the container database owns the processes and the memory, this SGA, and the overall architecture of Oracle database, and then each of the PDBs is essentially running kind of like a virtual database that's leveraging the different both the memory, the SGA, and the background processes. Of course, that's kind of gives you the benefit of a multi-tenant. You allocate the column store in the CDB or the container database in memory underscore size, and that controls the total amount, this area, this in-memory area here. And then each of the PDBs can allocate up to the total amount of the CDB's column store. But so say you had 2 PDBs, you could say in-memory underscore size equals, in our case of 16 gigs, 8 gigs for each of the PDBs, and each PDB could own 8 gigabytes of the total 16 gigabyte column store. You couldn't say for the PDB, well, I guess you could, but you could say if you said in-memory size equals 16 gig for both PDBs, then that's one's going to get it and one's not, because they're not going to start up at exactly the same time. So the idea being that the PDBs share the total resources of the CDB, and in the case of the in-memory column store, you can allocate, each PDB can allocate up to the total amount of column store, but they still have to share it between the other PDBs. So more typically what you would say is maybe one PDB would be in-memory size equals 0 because it doesn't need to have any column store, and then another PDB might say in-memory size equals 10 gigabytes and 6 gigabytes, and you can kind of divide that up. Now, so if you unplug a PDB, then obviously that would free up that PDB's space. But so all of those multi-tenant features work the same whether you use in-memory or not, but you can control how much in-memory column store you allocate based on that in-memory underscore size parameter. Do you want to add anything to that? I think I've got all that, but it's not really that difficult, but it's kind of hard to explain, I guess.
No, that was perfect. And close to what I wrote in my response.
Okay.
Okay, so then the next question, and I was frantically trying to look it up in the documentation there, was, are blockchain tables allowed to be in memory?
I don't have any idea. Blockchain tables. My guess is, well, I don't know.
I don't know either off the top of my head whether there's a restriction there. I mean, they appear to the application like a regular table, right. But that's a good one, and one that maybe we can do a follow-on office hour or blog post on.
Yeah, that's a good question. I don't know. Anything else?
No, that's it for this office hour. Okay. I want to thank you so much, Andy, for your time and all the info you shared with us over the last hour, and for answering all those questions. Hopefully folks found it really useful, and they'll join us next month when there'll be another Ask Tom office hours on database in memory.
Yes, thank you for everybody for attending.